Okay, so what we have here is we're going to address several situations with Newton's third law, um, dealing with objects that are accelerating and objects that are not accelerating. So the first thing we're going to do is we're going to deal with a runner standing at the starting line on a track. So we're going to draw a physical diagram of the situation. And because I am Picasso, I am going to draw a very good diagram of the situation. So here we have a green track, and upon this green track, we're going to have a, let's see how this looks. Let's draw a kind of a mauve. The mauve means purple, by the way. Runner standing on the track at the start-finish line. So we will put the start-finish line checkerboard. I don't mind doing checkerboard, but we'll say this is the start-finish line right there. And we're on a track. Here's the other side of the track. So you can see here that the drawings don't have to be anything really just technical. They're simply just drawings to help us visualize the situation. So what I want to start with is I need to draw a physical diagram. That's done. Check. And now I need to draw separate force diagrams for the runner and the track. So I'm going to start with the runner. So I'm going to stay with that purple kind of color for the runner. I'm going to draw that over here. And we know that with the runner, we're getting at least, if nothing else, we have the force of gravity. And again, you need to, well, we'll go ahead and do it here because this is important. On the runner by the earth. Then I'm going to have that same upward, which is going to be the normal force on the runner by the surface. We'll call it the surface. And then if I'm standing there, that's about all I have. Now, let's call it track. Let's go ahead and call it a track in this case. Track. So I'm done. And then we're going to come back. We're going to use the green to do the force diagram for track. Now, the track also has a mass going downward. And because the runner is standing on the track, we're just going to go ahead and call it let's do this. Okay, we have a FG on the track by the earth. And then we also have a weight the force applied, the force of the weight on the track by the runner. Okay, and then we know we need, because the track's in equilibrium, we need all these up arrows, and we have force normal on the track by the ground. So now we're looking for, so we have done this part now. We have the runner and the track. And I want to indicate any Newton's third law of pairs. So remember that with Newton's third law, for each action, there's an equal and opposite reaction. So what we're actually looking for here is these force pairs where the feeler and dealer have switched. So we're looking for something that's on this object by this object. So there's one. And then we're looking for something that is on the other object on this object, the track, by this object. So finding one where there's on the track by the runner. And then we find out that that one is actually right here. So this is a Newton's third law pair there. So Fn RT and FW TR are Newton's third pair. So that's how we identify that. And you'll notice that this one is bigger downward. because I do have that gravity from the track of self downward by the earth, and then the person standing upon that. And we have to have the equal upward force here because of that. Let's go to the next situation. Now we have a runner speeding up. So now the runner is accelerating, okay, following the start of the race on the track. This one may get a little bit iffy on us, but we're going to try this one just to see what we can come up with. So I'm going to have a runner again. So the runner is speeding up. So I know I'm going to have to show a, as a matter of fact, let's do this. Let's go here and do this one first. Let's do constant velocity. Constant velocity. I'm going to have this FG R E. And I'm going to have this FN R T. And then I know I'm accelerating, or sorry, I'm at a constant velocity and I'm moving. So I know that when I'm running, I have to keep pushing. And then we have to ask, in which way am I accelerating? I'm accelerating in this direction. So this arrow, according to my initial drawing, I'm not going to redraw it, and there's a force applied on the runner by the track, which is actually what's pushing us forward. And then I need a smaller force backwards, which is the force of friction on the runner by the track. Okay, so this is kind of one of those funny things, because we do have friction that's opposing us from the track, and then the track itself is also pushing us forward. This is what I said, and where it's going to get kind of tricky. So now I need to draw a force diagram for the track itself. Try to speed this up a little bit. So we're going to have that small downward. Okay, so we're going to have F, G, T, E. And then we're going to have a longer downward that is still F, W on the track by the runner. And I have that same upward force that matches the downward. And now the runner is applying a force to the track in this backward direction, right there. So that is the force applied on the track by the runner. And then something must be, the track itself is not moving, so there must be something indeed holding the track in place. So there is an outside force of friction probably on the track by the ground that's underneath the track. So again, we're looking at which one of these are equal and opposite. So when we come back to, we're trying to determine the ones that are opposite on the runner by the track, on the track by the runner. Those are the ones we're looking for. On the track by the ground, on the runner by the track. These two are the force pairs here. Oh, we are constant velocity too. I cannot believe you all let me do that. If we're in constant velocity here, then that has to be, I got ahead of myself. There we are, constant velocity. The fact that, so then this one is the same size as that one and is opposite, but they're different because this is on the runner by the track and this is on the track by the ground. So they're on different ground here and the runner here. These are not flip places. Only these two are flip places. I still have, for those of you that are wondering, I do, yes. I still have the ones here. This one, it would be this one. This one here is still a pair with this one as well. So that is still there.